The story of the cosmic microwave background. In the early 1960s, two young radio astronomers, Arno Penzias and Robert Wilson, were working at Bell Labs in New Jersey. They were using a large, sensitive radio antenna, originally designed for satellite communication. Their goal was to measure radio waves emitted by celestial objects, but they kept encountering an annoying, persistent noise, a faint, uniform hiss that seemed to come from everywhere in the sky. No matter what they did, they couldn't get rid of it. They checked their equipment, recalibrated their instruments, and even cleaned out pigeon droppings from the antenna, thinking it might be causing interference. But the noise remained. It was as if the universe itself was humming softly in their ears. Meanwhile, unbeknownst to Penzias and Wilson, a team of physicists at Princeton University, led by Robert Dicke, was working on a bold idea. They were trying to find evidence for the Big Bang theory, which suggested that the universe began as an incredibly hot, dense state and has been expanding ever since. Dicke and his team predicted that if the Big Bang had happened, the universe should be filled with a faint glow of radiation, a remnant of the intense heat from the early universe, now cooled to just a few degrees above absolute zero. When Penzias and Wilson heard about Dicke's work, they realized that the mysterious noise they had been detecting wasn't interference or equipment failure. It was the cosmic microwave background radiation, the afterglow of the Big Bang itself. They had accidentally stumbled upon one of the most important discoveries in cosmology. In 1965, Penzias and Wilson published their findings, and the scientific world was stunned. The discovery of the CMB provided the strongest evidence yet for the Big Bang theory, settling a long-standing debate between the Big Bang model and the rival steady-state theory. For their work, Penzias and Wilson were awarded the Nobel Prize in Physics in 1978. Why this discovery matters. The cosmic microwave background radiation is like a snapshot of the universe when it was just 380,000 years old, a time when it had cooled enough for atoms to form and light to travel freely. By studying the tiny fluctuations in the CMB, scientists have been able to learn incredible details about the early universe, including its age, 13.8 billion years, its composition, and even the seeds of the large-scale structures we see today, like galaxies and galaxy clusters. This discovery also highlights the beauty of science. Sometimes, the most profound insights come from unexpected places. Penzias and Wilson weren't looking for the Big Bang, they were just trying to solve a mystery. But their curiosity, persistence, and openness to new ideas led them to a discovery that changed our understanding of the cosmos forever.